Okay, this is the first question of the test, and just a little insight. I'm actually doing this problem last. So I went through and I did all the other questions first, and now I'm coming back to this. I realize that this is kind of the new question. It's one of the new types of questions that appeared in Chapter 10. Um, and I just wanted to spend a little bit more time looking at this and making sure that I had finished all the other tests and the rest of the tests in a reasonable amount of time. So I came back to it. I just want to quickly review some things about the calculator, how you set up and create a histogram and look at a 5-number summary with the data. So we've got, I guess it's kind of an interesting problem to me. It says when astronomers measure peak wavelengths of light emitted from two different stars, a lower wavelength may be an indication that one star is moving away from Earth faster than another. So you've heard maybe about red shifts or blue shifts or something from maybe an astronomy course. 18 wavelength measurements were taken in angstroms, that's a unit of length, for each of two stars in our galaxy during the year. So one's called Alpha Star and the other is called Omega Star. And we'll go ahead and look at these numbers. So I guess the first thing we need to do is fire up our calculator and get these values in it. In order to enter values like this in our calculator from this main screen, I would typically just hit Stat, and I'd go into my editor. And you can see there's some values in here already. If these happen to be the values I needed, someone else from the previous period left them in, I would definitely not just delete them, but these are not the values that I need. So I've moved my cursor up to where it says L1, and I'm just going to press clear and enter. So I've kept the list 1 in that spot, but I've cleared out all the values. L2 I'm going to clear also. If you open up your editor and you notice you don't see the list, the quickest way to re-establish your list is just to hit Stat and go Setup Editor, which is option number 5, and press Enter. And it'll basically just reconfigure your editor and make sure that the list 1, list 2, list 3, etc. are there. So I'm not going to enter all of these during the video, but let me just enter the first couple. So 4,317, and then I press Enter, and then 4,495, and I press enter. And again, this is not bivariate data. This is just one list of measurements. So I'm not entering these opposite each other. When I'm done, this is going to be sorry about that. When I'm done, get back up here. When I'm done, all of this data will sit in list number 1, not list LI. It'll be list 1, and this data will be in list 2, and then I'll be able to build my box and whisker plots from that. So let me enter the data here. I'll pause the video and do that. So I've completed going through and entering all 18 values for each of the stars, the Alpha Star and the Omega Star. And if I take a look at these now, I want to view this data as box plots. So I'm going to press second and go up to Stat Plot, and all of my plots are turned off, and that's a good place to have the calculator normally. I'm just going to go ahead and turn on plot number 1 and press enter here to turn it on, and I'm going to go down, and I could just continue to press the right over arrow button until I'm sitting right on top of my box and whisker plot. And I could look at it with outliers. In fact, that might be a good thing to do. Look at it and see if there's anything that the calculator triggers as potentially an outlier. So I'll go ahead and press enter there. And my data is being read from list 1, which is what I want right now. And frequency is 1, and there's the dot, the symbol it's going to use for outliers. So if I go ahead and press graph right away, I'm like, wait, I see nothing, right? Because my window is completely useless at this point, right? I'm going from -10 to 10 and -10 to 10 for x and y. If I look at my data, I think the smallest value in this first data set, I don't even see it. I don't see a super, I don't oh, this is probably the smallest one. So this 4,307, and it looks like my largest value is somewhere around 4,600. So what I'm going to do is I'm going to actually just change my window. So I'm going to hit window, and instead of my minimum my minimum x value on the x-axis being -10, I'm going to make it 4,300. And for my x value, I'm going to make it my minimum value 4,700. So when I'm looking at my x's that way, I should very clearly be able to see what's going on. So let me hit graph again, and there it is. Yeah, there's my box plot. That's awesome. So I am now looking at the alpha star. And remember, one of the beautiful things about having this in is that you can hit trace and you can quickly see all the important values, right? So I can see my minimum value is 4,307. I can see that quartile 1, Q1, it ends at 4,421. I can see that my median right there is at 4,488.5. You can see that it's an even data set, so I was definitely adding the middle 2 and dividing by 2. So 4,488.5. Q3 ends at 4,000, or Q3 is 4,585, and then my max value sits at 4,657. So those are all the values there that are important. If I'm going to try and sketch, this calculator is really helpful, but I've got to create a written record of this to turn in as part of my test. Probably the best thing that I would suggest is to come up with a nice consistent scale. I might say that this is about 4,300, and then every one of these I'm going to make about 100. So that's 4,400, 4,500, 4,600. That's too small. Let me spread this out more. So let's go, this is the 400, 500, 600, and 700. So this is 4,400, 4,500, 4,600, and then the final one's 4,700. So as I sketch my my first box plot for the alpha star, I'm kind of lining up the data points that I have here with this scale. So that I get kind of a consistent look for the two, and I can make maybe some comparisons a little bit easier. So again, my 5-number summary, and in this order, is this is kind of tricky. Let's see. The minimum value was at 4,300. So right here, 4,307. I'm going to say this is the start of this first whisker. Then off screen, I'm using my calculator. The next value was 4,421. So 4,421. Here's 4,421 would be about somewhere in here. Then the next value over is the median. The median's at about 4,488, which is not 500, right? But it's getting closer to the 500. So I'm just kind of looking at this value down here, and I'm saying that's about 4,488. Q3 is at 4,585. 585, not quite 600, but 585. And then the last value there is at 4,657. 4,657. So 57's kind of close to the middle of these two, so somewhere in here. So I kind of see, you know, this is this first box plot, right? I need to create the box here and here. One of the observations I have is this looks like a fairly symmetrical distribution. And notice that my calculator didn't identify anything that it considered to be an outlier. So there's the first distribution. That's for the alpha star. Now I think that I can come in, and I actually believe I can turn on the other one. Let me just turn on this second stat plot. I'm going to make it, I got to turn it on, and then I want to go down and make it a box plot with outliers, and I'm going to read this data from second list 2. Let me see how the calculator handles that. Oh, that's great. I love it. So it's coming through here, and it's overlaying this. And you know what? Now that I look at this, I think I can tell this window to make this just run from 0 to 10. Yeah, that puts this line down here more so I can see more what's going on. Now, if I hit trace now, notice there's two plots, right? You can see right now I'm looking at plot number 1, but if I hit my down arrow, I've toggled and now I'm looking at plot number 2. So I can read now all of the 5-number summary from my second data set. So I'm going to go ahead and jot these down as well. So the first one there is 4,432. 4,432. Ooh, about right in here. So somewhere in here. Yeah. And I can see that on my calculator, I can see that that whisker is basically where the other one's starting. Now I'll go over, and Q1 is at 4,531. 4,531. So here's Q1. And then I'm at the median 4,580. Just close to right here. I'm sorry, that was the median. Q3 is at 4,619, so here's 619-ish. And then finally the maximum value was 4,682, so somewhere just right in here. So with those, now I can come in and I can kind of finish off my, oh dear, sorry about that. I can finish off this box plot, this line and this line. This is terrible looking, and this and this. So I've got a pretty good idea of what the second one looks like. Now if I look at these, this one looks like the distribution is skewed a little bit to towards the left, skewed left, or the distribution skewed, I guess we would just say this here. Definitely this distribution has a much smaller range. And it also has a smaller interquartile range, right? Remember the difference between Q3 and Q1 is something we call the IRQ, the interquartile range. I've got my keyboard attached and it's kind of getting in the way. Let me pause the video for a minute and come back. That keyboard was helpful for typing in the data values, but it's not very helpful for here. Now, one of the things that you should do is you need to list the five. It says the 5-number summary, and use it to create a box plot. I didn't actually ask you to list the 5-number summary at all, but probably a good thing to do would be to list each of the 5-number summaries by each of their points. So let me pause this. I'll add that and show you what I'm talking about. Yeah, I've done this and I don't really like how it looks, but I think it's important information. So you can see this value is the minimum, this is Q1, this is the median, this is Q3, it goes with this line right here, and then this is the max right here. So again, if I take the difference between Q3 and Q1, that difference is called the interquartile range, and you can see that the interquartile range for this distribution is much smaller than the interquartile range for this one. And if you look at it too, this top distribution, the data from that tends to have smaller wavelengths, right? The alpha star looks like it's got, in general, smaller wavelengths. In fact, half of the data points for the alpha star are less than this median, and see, that's why it would be nice to have this median in front of me. If I look at it, the median was 4,488 compared to this one, which has a median of 4,580. And it says, if I interpret this, it says a lower wavelength may be an indication that one star is moving away from the Earth faster. So that means because the alpha star has, in general, the lower wavelength measurements, they tend to be lower. They're on average lower. This one would tend to be moving faster, right? A lower wavelength may be an indicator that one star is moving away from the Earth faster than the other. So down here I could say, what would be a report? I might say that the alpha star, right, the alpha star may be moving away from the Earth. I can't believe I did that, at a faster rate. So that's one thing that may be happening here. If I look at, this is the alpha star, and this was the omega star. So because you look at it, half of the data is below this mean, and half of it's below this one right here. So it tends to be the omega star tends to have a little bit longer wavelengths, which means it's moving slower. Now the other thing that it does say is it says compare the center, shape, spread, and outliers of wavelengths collected from these data. I would say that the center alpha has a lower center, right? Alpha has a lower center. Their medians, its median's lower. The shape, I guess the alpha distribution looks pretty uniform. When I look at it, it seems like the Q1, Q1, from Q1, Q2, Q3, and Q4 tend to have roughly the same number of points. So it looks like a fairly even distribution. Alpha has a lower distribution. It is a symmetrical distribution, while omega is skewed. And I'm just saying that because if I look at this point where the median is, and Q1 and the minimum, it appears that it's skewed left to me. I'd want to look at a histogram to really be kind of definitive about it. The other thing is that alpha has a larger range and a larger IRQ. So alpha has a LAR larger range. That's just minimum or max minus min, and a larger IQR. I always say RQ. It's IQR, interquartile ratio, or interquartile range, which is Q3 minus Q1, just for reference. That's what I'm talking about. And the alpha star has a larger range and a larger IQR. So you think about that, and you think about what we talked about, variability, and maybe standard deviation. Probably the omega star has these readings have a smaller standard deviation because the data is more it's more tightly compacted, while the alpha one with its bigger range and actually, I can't actually say if one has a larger standard deviation or not. That would be interesting to look at, though. But just in terms of the spread of the data and the IQR, interquartile range, it looks like the alpha data may be a little bit less predictable or less consistent than the omega star data. So anyways, this is definitely an introductory topic, right? This is new, and there's a lot that we're going to learn about this stuff, in Math 2 and Math 3, and then hopefully some of you will take AP Stats or CP Statistics as your capstone math course here at Shasta. But it's a good look at this right now, and a good look at the tool that we have for creating these box plots.